Roy Fielding published his dissertation, Architectural Styles in the Design of Network-Based Software Architectures, in 2000 for his PhD in Information and Computer Science at UC Irvine. In it, he described an architectural approach he dubbed REST, which operates on representations of resources using hypermedia. Few papers have had a greater impact on the design and architecture of web APIs as Fielding's work has. This is a best practices course, so our focus is more on coding practices than background information, but a couple of moments will help make the advice on practices make more sense. Let's quickly review what REST is, what it isn't, and some useful concepts we can take away even if we don't choose to fully adopt REST as our architecture of choice. REST simply stands for Representational State Transfer. Simply put, it is an architectural style for building distributed systems based on hypermedia and designed around resources. You'll find many web APIs describe themselves as RESTful or REST-ish. Most often, these leverage REST principles for resources, but omit hypermedia. So, what is hypermedia? And for that matter, what are resources exactly? Well, hypermedia is an extension of the term hypertext, which of course is the HT in HTML, Hypertext Markup Language. Any non-linear medium of information or data that includes the data itself, graphics, audio, video, binary data, plain text, etc., as well as hyperlinks, is considered to be hypermedia. The term nonlinear is applied here because the data can be explored by following any number of hyperlinks that may be provided with or in the data. Any audio cassette tape can only be consumed in a linear fashion, while you're able to jump to any arbitrary point within a digital music file. Books, especially fiction, are typically meant to be consumed in a forward-only linear fashion, but some books, like a Choose Your Own Adventure series book, allow you to make decisions and turn to a different page in a non-linear fashion based on your choices. REST architecture is built on the premise that hypermedia will be provided alongside data to facilitate navigation and interaction with the system. Clients don't necessarily need to know ahead of time all of the possible navigations available when interacting with a REST architected system. This is because the system can provide the navigation along the way using hypermedia. Now, REST is all about resources. In fact, that's what the first three letters stand for. No? It's actually not. I'm just making sure you're paying attention. Resources in REST may be any kind of object, data, or service that can be accessed by the client. A resource always has an identifier, which is a URI, a Uniform Resource Identifier, that uniquely identifies that resource. That's literally what URI stands for, Uniform Resource Identifier. For example, the World Wide Web uses URIs to identify individual resources such as HTML pages, images, applications, and more. Now, a resource in REST is any information that can be named. A resource may be a document or image, a temporal service that provides information that might vary over time, like a weather forecast. It could be a collection of other resources, or even a non-virtual object, such as a person. REST uses a resource identifier to identify the particular resources involved in an interaction between different components. And REST components do not transfer the actual resources, but instead they move about representations of resources. So what is a representation? This is why a resource can be a real-world object, even though we're only talking about digital communication between computers. Remember, fully half of the term REST stands for representational. No joke this time, that's what the RE stands for. REST components perform actions on a resource by using a representation to capture the current or intended state of that resource and transferring that representation between components. A representation is a sequence of bytes plus representation metadata to describe those bytes. You may also hear representations referred to as documents, files, HTTP messages, instances, or some variant of resources. These representations are passed between the server and the client. Now, one of the toughest problems in computer science is naming things, and that applies to your resources in your API as well. When designing your URIs for your resources, try to follow these practices. First, use nouns in your URIs rather than verbs. Remember that a resource is a thing, so its identifier should reflect that. Of course, a group of things can also be a resource, and since most web APIs expose more than one of most kinds of resources, the convention is to use plural nouns for almost every case. In order to specify a particular resource out of a collection of them, the specific identifier should be appended to the URI, usually separated by a /. One of the main goals in your API design is that you follow the principle of least astonishment. That is, you want to avoid surprising consumers of your API with things that don't make sense to them. The less they need to learn about your API and its specific idiosyncrasies before they can use it, the better. To that end, the two most important things to remember when designing your API's endpoints are to keep things simple and keep them consistent. If you have a convention you use for a certain kind of operation, be sure that you're applying it consistently throughout the API. When dealing with resources, avoid exposing internal details. Your API's resources should not be coupled to database table definitions, persistent store document formats, or your business domain entity designs. Instead, you should leverage encapsulation such that the resources your API defines and the internal details of your application can vary independently from one another. Remember, REST is all about state, not behavior. This is the key thing to remember about REST. The things you represent in APIs designed using REST architecture should all be nouns, not verbs. And as such, there is not really a place for remote procedure call or RPC style endpoints if you're following REST. Let's consider some different approaches for triggering behavior. In an RPC style interface, you might expose certain endpoints that allow external clients to invoke behavior on the server directly. For instance, a smart home API could allow a mobile device client to make a call to the service telling it to turn off the lights. There might be other APIs exposed for turning lights on or changing their colors, etc. Note that HTTP doesn't have any standard support for RPC, so the server and client would need to agree on a protocol to use that was outside of typical HTTP standard usage. Post is frequently chosen since RPC-style calls typically change the state of the system and are not necessarily safe to repeat, just like most POST operations. Using a REST approach, however, the desired state of the resource would be sent to the server using an appropriate intention-revealing HTTP verb. In this example, since the resource in question is a smart light bulb and it already exists, the put verb is the most appropriate one to use for this operation. Along with the verb, the new desired state is passed in the body of the request. It is up to the server implementation to determine how to change the state of the resource to the one that has been indicated in the put request. REST has a lot of good guidance for describing and organizing resources, but it doesn't try to invent its own way to manipulate resource state. Instead, it relies on existing HTTP standards for describing desired state manipulations. This is a good thing, as it reduces a lot of design choices we might otherwise need to make. Instead, we can just follow standard guidance. Another option for dealing with long-running processes is to create a noun that represents the process itself. We can introduce something like a job, a process, or an operation, and then use that as the resource that REST is representing. In this case, we could post to the server a new job that we want the server to begin performing. The server, in turn, creates the job and returns back a location header where the state of the job can be monitored. Then, the client is able to poll that location to check to see what the state of the operation is. The server will continue to return a series of 200 OK responses while the job is not yet complete. The client may also have an option to cancel the job. Assuming that the operation completes successfully, then eventually the server returns a result which includes the location of the operation's result. Then the client is able to make a GET request to this new URI, which in turn will provide the output from the long-running operation.